Hi everyone, this is the video lesson for Pascal's triangle and binomial theorem, day 1, part 1. Now before we start, in case you're thinking about grade 12 math for the coming September, and if you're thinking if data management is the right course for you, this lesson, Pascal's triangle, is going to be in the data management course. And if I remember right, it'll be specifically chapter 4, section 4, and chapter 4, section 5. Now, here we go. Pascal's triangle is a triangle where the first number is going to be 1. And all the numbers that are diagonally to the left and also to the right remains to be 1. So before we continue, you can put in all these numbers. It's just going to be 1 all the way to the bottom of this triangle, just like that. Now to find the next number, what you do is you're adding the two numbers from the row above. So for example, the reason why we know this entry is going to be 2 is because from the row above, you take 1 plus 1, which is 2. That is right. This is grade 11 math. 1 plus 1 equals to 2. So likewise, if you look at this number, 3, you take 1 plus 2. Likewise, 2 plus 1, that's going to give you 3. So we're going to keep going. There are a lot of different ideas we can extract from Pascal's triangle, but let's at least write as many numbers as possible. Again, you can feel free to take a calculator and try this with me. You want to do mental math? That works too. So 1 plus 3 is going to be 4. 1 plus 4 is going to be 5. 4 plus 6 is going to be 10. 4 plus 1 is going to be 5. Let's keep going. 1 plus 5 is going to be 6. 5 plus 10 is 15. 10 plus 10 is going to be 20. Now before we keep going, notice the pattern. We haven't even gone all the way to the bottom yet, but if you think about the left-hand side of this triangle and the right-hand side of this triangle, I'm hoping you see the reflection or the symmetry from both sides. So you can predict that the next two numbers should be 15 and 6. And again, if you add them, 10 plus 5 is 15. And likewise, 5 plus 1 is 6, just like that. Now the only condition is you're doing it right in the first half. If not, you're going to copy the mistake twice. I'm going to go slightly faster now. 1 plus 6, that's going to be 7. 6 plus 15, that's going to be 21. 15 plus 20, that's going to be 35. And again, if we follow the pattern, it will be the same numbers on the other side. 1 plus 7, that's going to be 8. 8 plus 21 is going to be 28. If you keep going, that's going to be 56, 70. And again, it's going to go back down to 56, 28, and 8. I'm going to go even faster. Again, you can take the calculator, you can do mental math. It should be 9, 36, 84, 126, and again, same numbers on the other side. 1 plus 9, that's going to be 10. 45, 120, 210, 252. And again, the patterns reoccur. Now, let's keep going. There are 16 rows, but we'll get to row 15. So this is going to be 11, 55. Let's zoom in so you can see a little bit better. 165, 330, 462, and again, the same numbers on the other side. Now at this point, what I would suggest is you press pause. You can take the calculator and work this out. And of course, when you press play again over here, I just noticed I made a mistake, of course, as I'm doing this with you in real time. This should be 462 as well. And the rest would be like this. So, okay. So again, keep going. Press pause. Do the rest of this. and when you press play again, I'll be right here and I'm going to finish it with you. Okay, let's keep going. Let's work this out. So in the next row, and we'll talk about the row numbers in a moment, 1 plus 11, that's going to be 12, 66, 220, 495, 792, 9, 24, and again, the pattern recurs, just like that, 66, and 12. And of course, if you want to go the other way, that works too. 12 plus 1, that's going to be 13. If I keep going, 78, 286, 715, 1,287, 1,716, and again, it will be the same on the other side. Again, notice if you made a mistake, everything else that follows would also be consistently incorrect. We're almost there. 2 more rows. You can do this. 14, 91, 364, 1001, 2002, 3003, 3,432, and again, the rest of this half should be the same, just like that. 91 and 14. Okay, row 15, here we go. 15, 105, 455, 1,365, 3,003, 5,005, 6,435, and again, the rest of this half will be the same. It should be a reflection with respect to the other side. 3,003, 1,365, 455, 105, and of course 15. Okay. Now again, you don't have to do this every day, but if you understand how to compose the triangle, then you're ready for step 2. Now again, there's a mix of Pascal's triangles in terms of this course and the grade 12 data management course. So I'm going to give you a little bit more. If you really go back to the beginning, and this is where the vocabularies are important, a lot of students make the assumption that the first row will be row 1, and that's, I get it, that's how you would think about it. But technically speaking, the first row, this is called row 0. The second row is called row 1. The third row is going to be row 2. And again, if you continue this is going to be row number 3, and so on. So again, in case you're thinking, I don't get it, how do I correlate this? So you have to focus on the diagonals. And the pattern is, if you look at these row numbers, 0, 1, 2, 3, and so on, you basically look at the second diagonal. So again, this is called the second diagonal. And a preview, of course, is in data management. If you're learning chapter 4.4, 4.5, the next diagonal is the most powerful diagonal, especially for 4.5 when you're solving word problems using Pascal's triangle. But anyways, that's more of a grade 12 concept. If you get back to here, one idea right off the bat is the row number. Now, another pattern you should notice is what happens when you're adding all the numbers for each row. So for example, in the first row, also known as row 0, the sum is going to be 1. In the second row, 1 plus 1 is going to be 2. 1 plus 2 plus 1, that's going to be 4. 1 plus 3 plus 3 plus 1, that's going to be 8. And I hope you see the pattern. You really need just 4 terms to get a clear pattern. And the pattern continues. And of course, the question becomes, how can I write down a formula? So 1, of course, is 2 to the power of 0. 2 would be 2 to the power of 1. 4 is 2 to the power of 2. 8 is 2 to the power of 3. 16 is 2 to the power of 4. 32 is 2 to the power of 5. And now if we correlate this to the row number that we described just now, you would discover that to find the sum of row n, so 4 row n, the sum of that entire row is 2 to the power of n. So that's the second idea you want to extract from Pascal's triangle. And of course, the third idea, and maybe I can address this as I'm reading the questions at the bottom, is to look for patterns, try to answer the following questions. Can you predict the next row of numbers? And this is the first thing that we did when we composed the entire triangle. So can you predict the next row? The answer is yes. But that's not enough. We want to keep going and kind of talk about how we know this. So technically, there's a name for this. It's called Pascal's Identity, which really is in a data management course. So I'll even put a little note next to this. MDM for you. And this we cannot really talk about until we get into combinations. So I'm going to just write it like this for now. And in the next part, I'm going to explain this in detail in terms of combinations and choose R. What does that even mean? But I'm going to come back to this, okay? It is a grade 12 concept. I'm not going to dismiss this. I just want to make sure you're thinking about this. But the short answer is you take 1 plus 1, which would give you 2, right? So maybe the hint I'll give you for now is 1 plus 1 is really just this right-hand side. And of course, when you add them up, that would give you 2. So keep trying the rest of this. Number 2, 3, and 4, add the numbers in each row. Is there a pattern in the sums of these numbers? Do these numbers repeat? Can you find a pattern in the diagonal numbers? We kind of talked about this. Just try this. I'm going to see you in part 2, and we're going to continue with more math. I hope this makes sense.